All right. So we did the types of data there. Now, underneath it, what we deal with is data that is quantitative. All right. And there's two types of quantitative data. All right. So this was, let's see. So right here, quantitative data. All right. Quantitative data can either be so there's two types. All right. The two categories for data, and if you click to the next slide on the Jamboard where it's got discrete and continuous, those are the two categories. All right. So data can be either be discrete or data can be considered continuous. Now, it matters what they are, guys, because the way that you represent them in graphs is different. All right, first of all, let's describe what they are. Okay, so when we say the word discrete, now, most of the time, the word discrete kind of means doing something on the down low. All right, so if I'm being discrete, I'm not trying to bring attention to myself. That is what discrete means. Now in mathematics, it's different, it has a whole different meaning. You can actually take whole courses in discrete mathematics, okay? But when we're talking about data, discrete means the numbers that we're dealing with, the numerical data that we're dealing with, it takes on exact number values, mostly whole number values, okay? So this takes on exact number values. Okay, so that means there's no rounding is involved. All right, often the result of counting. So you can almost think of discrete data in most cases as something that you could count. So when I count, I go, it's one number jumps to the next. There's no in between. So it's 1, 2, 3, 4. It doesn't go 1, 2, 3, 3 1/4, 3 1/2, 3 3/4, 4. It just is 1, 2, 3, 4, etc. Okay, that's discrete data. So an example of discrete data would be the number of desks in the classroom. I could count those up. All right, I'm not going to have a half a desk or anything like that. Okay. If I count the number of fingers on my hand, that would be discrete data. All right. I've got 5 fingers. Okay. 1, 2, 3, 4, 5. Okay. Now on my other hand, I've got 1, 2, 3, 4. I don't say I've got 4 1/4 of fingers because of this finger being cut off in a horrible lunch meat accident. Okay, but they're whole numbers. So think about them as things that you can count on your fingers. Okay, all right. Continuous data, okay, it can take on any number value. All right, so you could have 4.023. Okay, you could have 4 7/8. Okay, you could have negative 10.25. All right, that's what continuous data is. So continuous data can take on any numerical or any number value. All right, so most of the time this involves some kind of rounding. Okay, let me spell number right. I am a math teacher, for Pete's sake. Don't want that to get out on the interweb. All right, so, but when I measure something, I'm usually approximating it depending on how accurate I have to be. All right, so it usually involves rounding. Okay. It's something that can only be measured approximately. Okay, so if I measured the length of this, if I had a line and I was measuring the length of it, okay, it's still just an approximation because it all depends on how accurate my ruler is and how big the scale is or how far the scale goes. Okay, so for example, if I measured the length of this, well, my ruler only goes to 1/10 of a centimeter. So I could say this is 6.23 centimeters. Okay, I could say it's 62.3 millimeters. But if I had a more accurate or a finer ruler, then I could even go further. You know, I could, instead of going 6.2, oh, this is just 6.3. Hold on, I messed that up. Do it again, Krolak. 6. We'll say 3 or 63 millimeters. All right, and that's as accurate as I can get because of my ruler. But if I had something that took these little millimeters and cut them into pieces, then I might be able to measure that and I might get 6.32 centimeters. But my ruler doesn't allow me to do that because it's the smallest increment is only a millimeter. So that's true for anything. If I weighed something, you know, if I got on a scale and, you know, the scale said 100.5 kilograms. Well, if I got on a more accurate scale, it could go 100.5, maybe 2 or 1. And if I had a more accurate scale, maybe 3 places. Or if I had a more accurate scale, you know, maybe 4 or 5 places. So I could keep, depending on how accurate my scale was, I could keep getting a different number that is goes out to more decimal places. This is an example of continuous data. I can measure it, but depending on what I'm using to measure it with, it's always going to be some sort of approximation. Okay, so what this usually involves is these numbers take on a value to a specific accuracy, like, for example, 2 decimal places, or nearest hundredth, nearest tenth. Okay, that's an example. So if you came in and you measured your height, you know, I might round it to the nearest inch, but you know, depending on the ruler I had and how much time I had, we could get your height really accurate, but you could always get it more accurate depending on the type of equipment that you have. If it could measure your height more accurately out to more decimal places. All right, so that's the difference between these two. So for example, Kavisha did a project for her, I think it was anatomy class, where she was measuring people's heart rate and body, I think it was body temperature and reaction time based on a color that they were exposed to. You know, so certain colors she hypothesized would create certain types of reaction. Okay, so if you were collecting heart rates, Kavisha, would that be qualitative or discrete or continuous data?
I'd say continuous.
Yes. Yep. Because now if I was doing heart rates, you know, we do heart rates in beats per minute, but you could really, you know, like an EKG or something, measure, well, you know, 100.5 heartbeats. Okay, just because heartbeats are always rounded to the nearest whole number, you could get more accurate based on how you were measuring it. Now that doesn't happen if I was counting. So if I had these pens and they were standing in line, you know, to get help to this hand, well, there's 1, 2, 3, 4. There's no way of saying 4.5 or 4.25, etc. So the easiest way to think about continuous data is anything where you're measuring length, you're measuring, you know, distance, time, weight, volume, because all of these could be measured, but you're only going to be being able to measure them to a certain accuracy. And that's what this statement right above it means. It might be to the nearest tenth or the nearest hundredth. Okay. All right, so now let's go back up to your Jamboard and go on to the second part here, second page, and I want you to slide these over like we did on the first one to the correct category. All right, so let's do, let's see, where do we leave off? So Michael, you got number of or the volume of water.
The volume of water.
Yep.
Is continuous.
Yep. You slide it one way or the other. Yep. Okay. Next one. Jaden, number of airplanes. JM. Okay. Okay, go ahead and move it. All right. Let's see. Sally, you got the taxi speed. All right. Tyler, you got the number of bags of popcorn sold by the track team. Tyler P. Okay, the height of a tree, Kara. Okay, the number of M&Ms in a bag, Laura. Okay, now this should say the time taken to get home. All right, Braylon, the time taken to get home from school. All right, Mackenzie, Waylon, the number of computers a friend of yours owns. Mackenzie Whalen. All right. Let's see. Brittany, time spent studying. All right. Ethan, the length of a room. And Caden, the number of relatives you have. K Bluff. Okay, Braylon, are you there? Or is she at, oh, Braylon's here today. Earth Braylon, come in. Okay, Miss Clough.
Yeah.
Number of relatives you have, continuous or discrete? Okay, put it over there, please. Discrete. All right, the time that it takes to get home, Carmela, discrete or continuous?
I think continuous.
Right, anything that's time. Because you could always measure time. Like if I was timing a sprint, an Olympic sprint, and I could go to tenths of a second, I could go to hundredths of a second, I could go to a thousandth of a second. Okay, I could keep going finer and finer and get further and further to get more accurate, but still, it would still be an approximation, even if I went out a whole bunch of places. All right, so let's see what we got here. Do we agree with these results? Anything that should be switched? Number of relatives that you have is discrete, right? Okay. Volume, height, perfect. All right, very good. Okay, what do we got? 4 minutes? Okay, we'll stop there, guys, for today. And we'll pick up with, tomorrow we'll do identifying populations and samples. What's a population? What's a sample given a particular survey? All right, have a good day, everybody. I'll see you tomorrow.